Hi, we're going to go ahead and look at notes 2. This is composition of functions. This is the IXL you're going to be using. It's pre-calculus A12, so that's due. I'll give you guys a sheet of your scheduled IXLs. So we're going to look at functions, and we're going to look at functions and their inverses. But basically, we're going to look at composition or combinations of functions. So inverses is something we're going to look at later. So let's go ahead and look at composition of functions. So you have your given. So the functions f and g are defined as follows. You're going to show how to write a function for a given input. So basically what you're doing with f of x equals 2x and gx equals 3x plus 1, you're going to embed or compose functions. Or embed. The first thing you're going to learn is notation. So with notation, it's very specific. Notation can be confusing for some students, so we need to go over what that notation is going to look like in our situation. So notation is going to be like this. So f of g of x equals f function with g embedded. So g is your input. And then you can have g of f of x, and you're saying that you have the function g and f of x is your input. So the way that you say this, you say g of f, okay? And again, this is your input. So it's basically like substituting a function into another function. Okay, so we're going to ask you how to find f of g of x. Let's change the notation just so we know. That's going to be g of x inputted into the function of f. So the way that looks is we have our functions right here, right? And we're just going to work through them. G of x is going to be x. So you're now saying that f of g of x is equal to 2. Again, the input is a g of x, 3x plus 1. This is multiplication. 3x minus or plus 1. So again, this is your input. You always want to do PEMDAS. Okay, so let's go ahead and distribute. We're going to distribute the 2 into the equation. So 2 times 3 is 6. And then bring down the x, because that's still part of it. So it's 2 times 3x is 6x. And then 2 times 1 is a positive 2. So f of g of x, this is your solution. Okay, next. Now we're saying that we have f is the input into g. So we're going to change the notation. You don't always have to do this, but you want to go ahead and know what it means, because on your worksheet you're going to have both. So again, this is the input. This whole function of f, which is 2x, is going to be x. So from here we go g of f of x equals 3 times 2x plus 1. equals 6x plus 1. And we only need to distribute the 3 to here. This is the only place we need to distribute the 3. And so that's your solution. All right, next one. Just more examples. So if I say I have f of x equals 4x plus 4 and g of x equals 3x plus 7, one of these is going to be the input. It's usually the second. So right here, this is going to be your input, g of x. So you're basically saying that this whole function right here is going to represent this 1x. Okay, so let's see what that looks like. So you're going to say 4 times something plus 4. This is my input. So again, this is the input. Goes right there. And you're going to say 3x plus 7. You want to do PEMDAS. So you're going to distribute. You're only going to distribute the 4 into the g of x. So you're going to distribute like that. You're going to get 12x plus 28 plus 4, 12x plus 32, and that's going to be your solution. So it equals f of g of x. Okay, so number 3, f of x equals 3x squared minus 5x minus 3, and g of x equals negative 2x. If you look at the function, the g of x is the input. So this whole thing goes where I see an x. So negative 2x will be squared and then multiplied by 3. Negative 2x will be multiplied by negative 5, and then you'll simplify. So let's see what that looks like. Also, let's talk about the notation again. So if I were to write this out as another notation, it would be f of g of x. That's the exact same notation as this and that. And we talked about that right here. We should just highlight that. We'll underline those. That way you know the two different types of notation. Notation is really, really important in this case. So I highlighted the two different notations that you should know. Sometimes you have different variables and you'll do that in your worksheet. Okay, so going through this, you are going to basically say that you have wherever the g is, wherever the x, you're going to put the g of x. So you're saying f of this function. This is just another method. But these are the same thing, okay? So you have this method and you have this method. So what that means is 3 times negative 2x squared minus 5 times negative 2x minus 3 equals. This needs to be distributed to each term. So it's going to be 3. Negative 2 squared is going to be 4 because you're doing order of operations. So you need to look at exponents, and then x squared is x squared, and it stays in parentheses. You're going to distribute the negative 5 into the negative 2, so that's important. A negative times a negative is a positive, so plus 10x. And then there's nothing to combine here, so you simply bring it down because this is a number sentence, so it all goes together. And then you keep on simplifying. 3 times 4x squared is going to be 12x squared. There's nothing else, plus 10x minus 3. So you can say f of g of x is equivalent to this. Because then remember that this is f of g of x. Because this right here is your g of x, which is your input. Okay? Okay, so now let's look at how we can embed a g of x into the f of x and then the f of x into the g of x. So we call them problem sets because you have one given and then you have multiple problems in for one problem, basically. So let's change the notation. And I just want to stick with the notation, that way we know how to look at it both ways. So f of g of x means g of x is going to be the input into f. So g of x, so this is your input. And then this one is g with the input of f of x. So that's going to be my input. Okay. Alrighty. Let's call this A, let's call this B. So A. So f of g of x, again, this is my input. So it's going to be -3 times -3x plus 9. It's times the whole thing. And then if I continue it, -1. And you're going to distribute because you have to do PEMDAS. So I'm going to distribute the -3 into the first term and the second term. 9x minus 27, bring down the 1, minus 1. So I get 9x minus 28 equals, it doesn't matter if it's, say, g of x equals on the left or on the right, f of g of x. Just put a box around that. Okay, next problem. So we're going to have this problem B. And we said that f of x is going to go into g. So this whole thing right here is going to go where I see the x. So this is going to be -3 times the input right here of the whole f of x, -3x minus 1. And then don't forget to add the 9 plus 9. And then it's PEMDAS. So we're going to distribute. Negative times a negative is a positive 9x. Negative times a positive is a positive 3 plus 9 equals 9x plus 12. That is your solution. Okay, this is your last problem. So let's go ahead and look again at the notation. We're going to say that this is f of g of 1. And then we're going to say that, we'll call this one A, call this one B. And we're going to say that this is g of f of 2. So again, you have your input These are your inputs. But now you're saying that x equals 1. And then here you're going to say that your input where x equals 2. The first thing that we're going to do is A. And it's going to take a couple steps. So just be patient. You're saying that x equals 1 for G. So you can say f of x equals 3x squared minus 5x minus 3. And you can say g of x equals 6x. But now we're also saying that g, instead of g of x, you have g of 1. So you say that g of 1 equals 6x. So remember when I said the input is 1? I'm talking about x becoming 1. So then we substitute. And we say 6 times 1 equals 6. But again, the reason why we work down, because math is linear. So if I say that g of 1 equals 6, and I said, okay, we want to input this whole function into here, you're now saying that this 6 can go right here and right here. And let's see what that looks like. Equals 3 times 6 squared minus 5 times 6 minus 3. You have to do PEMDAS. PEMDAS is always, has to be done. That's why I always write it. So it equals 3 parentheses exponents. Exponents are right here. This is still multiplication, so it's times 36. Multiplication, that's multiplication right here. So 5 times 6, it's negative 5 times 6, which is negative 30 minus 3. Okay, so 3 times 36, let me just do that on a calculator. It's going to be 108 minus 30 minus 3. And that's going to be 75. So you're saying that f of g of 1 equals 75. Okay, for our second part of the problem, this is B. Again, this is g of f of 2 equals this notation. Whichever you prefer is what I want you to use, but you have to be able to use both. So if I have g, I have 6x is my g, and then I have my f of x equals 3x squared minus 5x minus 3, and it's kind of messy. Okay, and then you're basically saying that you have f of 2, so let's go ahead and solve that. If I have f of 2, 3 times 2 squared minus 5 times 2 minus 3, order of operations. So I have an exponent, so 3 times 4, negative 5 times 2 minus 10, and then minus 3. All right, 12 minus 10 minus 3. So I'm going to get negative 1. So that's f of 2. And this right here is your input back into g of x. So you're saying basically that you're going to have g of negative 1 equals 6 times negative 1 equals negative 6. So that's your solution for g of f of 2 That's it. All right, see you in class.